Hello everyone, and welcome to this webinar. We are going to be waiting for a couple of minutes for people to start joining, and then we'll get started. Okay, so we have a bit more people joining. In maybe 1 minute, we will get started, giving it some time to everyone to join. Okay, perfect. So I think we can get started. So hello, everyone. My name is Alfonso Zamarro, and I am the CEO and co-founder of Unblur. And today I'm going to be your moderator for our Smart Talk webinar from Unblur. This is the second session we are running on situation awareness and how technology can actually support frontline first responders on making decisions and operating in a safer and better environment, basically. Today, we're going to be talking about the data that's coming from the field, really, about how drone technology, how thermal imagery, and how integrating all of that together into a incident command environment can actually support incident commanders to really become greater leaders, isn't it? Because at the end of the day, that's the trick. No, technology offers great potential. We always hear about how this new piece of technology can help save lives, but there is a big question on how can we actually adapt it to this very tricky environment, which is the front line of an emergency. And today we have here a few people that are actually shaping it and making it possible. So we're going to have Lars Axelsson from an expert on FLIR technologies and thermal imagery, and also Romeo Durscher talking about drone technology and this new concept of open platforms for drones, basically. We're also going to have Scott Hurfel from Shropshire Fire Service, but he had a last minute issue, so he won't be able to join us today. but for sure you will be able to see him in some of our future webinars. So starting with our first part of this panel. So starting with Lars. Lars is, as I said, a FLIR technologies expert. He's basically training firefighters on how this piece of technology can be used during their daily tasks and operations. He has been doing training in more than 50 countries around the world, teaching firefighters. And himself, he's also a former firefighter and a watch manager in Sweden. So, floor is yours, Lars.
Oh, hello. Well, that's sort of true, at least. I don't know. Expert is just such a hard thing to melt. I consider myself to be a nerd. I like this, so that entails me to try to find more things. So where do you want me to start, Alfonso? About thermal imagers?
Yes, definitely. Tell us a bit more about the work that you're doing and how thermal imagery is actually helping many of the students that you're training globally.
Well, thermal imagers, my focus is primarily on firefighters and first responding officers, like the first part of the incident, which I would consider most interesting and also most critical. Like then you have command coming later, and we'll get into that. But the first part and thermal imagers is not complicated in itself. It's just adding another sense. Of course, you can see now, you can orientate yourself better inside a fire compartment, and you can of course see heat. You can see where heat is coming from, maybe, and so on. So thermal imagers is becoming a absolutely essential part of doing firefighting. If you're not using a thermal imager, and if you're not using a good thermal imager, you're handicapped as a firefighter going inside, or for that matter, standing on the outside looking at a building and finding heat patterns and heat signatures. So thermal imagers is a no-brainer in terms of it has to be used in firefighting. The problem is, when I started with interior firefighting, it was sort of a small problem for the firefighter. Okay, you have to teach the firefighter how to use the thermal imager, and that's your sort of like how do you interpret the picture and so on. But that makes a lot of sense for firefighters and so on. But it changes tactically. It changes a lot. It changes how we view, how you incorporate into like fire training, just to start with. If a lot of times you put it in the last in the training, and then everything that comes before sort of get messed up, because you will act in a different way when you have a thermal imager, because you can move much faster, you can find things faster, you can find the fire faster, and so on. So you have to start using it very early. And then also tactically changes a lot of things, because it changes how the speed of the incident, meaning you can do things a lot sooner. You can go to ventilation a lot faster because you're arriving to the fire faster, for instance. And that changes tactically how you have to adopt. And that changes the pace on the outside for instance, for the officer who makes decisions. So the first one is that, I realized that it takes a lot of time to change that culture, going from basically no tick or bad tick to good tick. And most departments, I would say, have not made that switch. It's still like searching left hand at the wall or right hand at the wall. Well, some have done different types of implementations, but there are very few departments, I would say, that fully integrated the thermal imagers for inside view. But then also we have the outside view. We have like for officers and external scans. And that for me was more problematic, because we have, as a first arriving officers, you're seriously overloaded with problems and information. Like going in front of a building and you teach them, okay, there's a thousand things I could look at a building, like how is it constructed? Like, does it look decent shape? Like, when was it constructed? What's the construction type? Will it fall down on my firefighters when they enter? Like that alone is a serious question. It can take you 10 minutes if you really want to try to focus on, is that a safe building to operate in, and so on. And then you have to look at fire behavior and all the different cues. Where are my inlets and outlets, and what's the smoke doing? Where's the smoke going? Like, that's where you get stuck in analysis paralysis. Basically, you can just start processing and processing and processing. You can't, worst case, you never get out of it. You never make an order because you're stuck in that loop. And adding thermal imagers just adds adds even more of that information coming in. Now you have a different sense. You look at heat patterns on the buildings and so on. So the information overload is like a serious problem. And the more I learned about firefighting as a nerd, the harder it got. Like the harder I wouldn't say I became a worse officer, but I noticed that I became that my perception of myself was that I was becoming worse, because the more I learned, the more things I wanted to look for and analyze. And the more things I learned and analyzed, I thought I would make better decisions, but I don't have time. Like there's too much to analyze in that small perspective. So it's sort of like ignorance is bliss. The less I know, the easier it is to make decisions. And that's, of course, that we make simplifications. We make, standard operating procedures, guidelines, and we divide the buildings into different types and say, if you have this type of construction, that's sort of safe to go into. You don't have to think about it that much the first 20 minutes, maybe. And those are generalizations, and they usually work, hopefully. But sometimes they don't. And then you go, oh shit, and someone dies or someone gets hurt, because we don't have time to digest that information properly. So ticks are essential for firefighting. They're essential on the outside for giving you that extra layer. But the problem for me, again, was that it creates just another thing to do, another thing to analyze, and we don't have time. Now, when I started in the fire service was, after 2000s, there wasn't really a solution for this, at least not practically, because I mean, the only way you could sort of solve that, at least to me, was to divide the workload, like more people, more brains processing the information. And that was not possible because we couldn't add more fire stations that early on. Like there was, there's going to be one fire station responding, and that officer or that firefighter, whoever arrives, is going to be the single brain operating that incident. And of course, you send firefighters in and they have their domain. They're trying to process a smaller part of the information inside, but there's still just one brain trying to have command. So there wasn't really a workaround. But as soon as we got technology, like if you place a camera on the firefighter, just a simple GoPro camera, and you send that feed into a back, incident command station or some kind of rear command, now you have more brains, at least in theory, able to be interpreting that information and analyzing it. Now, in Sweden, we had that was when I first started about that, I got pretty much shut down because rear command should not do things on a second-to-second basis. The intention of rear command was to work with longer time arrows, like they should work strategically and with resource management and other things like that. And if you put a monitor with a live feed from a fire, everyone glues to that monitor and nobody looks at the long term. So that was the argumentation I got to me, and I said, they're like, I'm buying that, but that doesn't, don't throw the fish, the baby out with the bathwater. I think you could do both. So what I wanted back then, and I was never in a position to do anything about it, but what I argued for was, like, we need to send that information to more brains. Like how or where, I don't know, but we have a lot of people, like we have the technology to send that information to whoever the officers are around my station, for instance, and they can get a beep on their phone and they look it up and they get a screen and they say, oh, that's a fire here. Let me help you analyze it. And then you get their task with building construction, for instance. They'll go like, I'll only look at building construction. If I see anything noteworthy, I'll send a digital ping on the officer's shoulder and say, hey, I have something important to say. So technology added us a way of, from the very start of the incident, or maybe even before, if Dr. Mayer is going to send a drone, and so we get live feed before the officer arrives, which would be awesome. But like we get possibility to have more brains interpreting that information early on, which is technology does. But it's very few departments around the world that's actually using that in any sort of way for helping the first arriving officer. And of course, if we add thermal imagers to that, we add another sense that we can help to analyze the situation. So during my career, you know, all the tablets came along with all the different tools that were supposed to help the system, you know, like how the system reacts. But many of them was actually just an add-on workload for the first responding officer. It didn't alleviate the workload, it added workload. It maybe made something better for other people. Like rear command got more information. Rear command could make better decisions, but it was an added workload for the first arriving officer. And that rarely works because again, you get information overload, you have time restrictions. So most of the things we try to do, like checklist on an iPad, they generally never used, at least not at first responding officers, because you don't have time to use the help that you're given. So it's not really help. It becomes increased workload. So again, going back to, I think that why I was interested in joining this talk was the problem we have of information overload. I only see one solution. It is again involving more brain. And to involve more brains, you have to have something somehow taking information in from all the sensors we can get, drones, cameras, thermal imagers, it is databases, whatever it might be, taking all that information in. Has to be a lot of brains processing and analyzing that information far away from the incident. And then you have to have some kind of spider in the web that says, this is important, and tap the incident commander on the shoulder that's on scene and say, hey, I have something of importance that you need to look at. And I have never seen or found that spider in the web thing, at least not something that works really well. When you stretch out the incident, you go to a longer incident, 20 minutes in, an hour in, 2 hours in, and you establish more of a command on site with more brains. Well, then it's easier. That we do that because we need more brains on scene. We need that, but the pace is also slower. It's much easier to implement something back then because you can have a dedicated drone operator, you can have a dedicated board operator, you can divide the workload on more brains. That is easy in comparison to the first 20 minutes. That's where it is. If it doesn't work the first 20 minutes, it's not going to work really well on command. But if it works on command, it's not for sure going to work on the first arriving officers. So, and the problem with command is that you have even more information then to deal with because you have even more sources, many different officers reporting in or firefighters reporting in. And again, technology is starting to report in. But it's easier to build that infrastructure to involve those more brains and divide that. So again, the reason I'm interested in this is because I feel that technology is ready, and it's been ready for quite some time. But to connect them together so that it actually becomes a help for the officer rather than an increased workload, that's where I see the absolutely biggest challenge.
Yeah, I think you touched many very, very interesting points. Actually, no, I think one of the key highlights that I'm also getting from what you're saying, and I heard about it a lot, is the fact of talking about the first team that arrive on scene, isn't it? These first minutes, because usually when we think about technology and using softwares, using devices, etc., indeed we need people, and this is usually deployed when it's a large scale incident. No, then you have all these very sophisticated incident command units with great technology, isn't it? But some of the comments and challenges we heard, it's mainly two things. One of them is, why invest in so much for something that maybe we use once per year, you know, or not so often. And then the second one is that whenever the time comes to use it, because you don't get to use it that much, then actually you are not familiarized with it, or you don't really get the most out of what that tool could potentially give you, no? And the second point that I think it's very interesting on what you're saying, and I think that's where the technology is actually going to support. It's not that much on having a format, a checklist, isn't it, on a piece of iPad, you know? Because at the end of the day, why not doing it on paper? You know, like investing money on a tablet, you need power, potentially you need internet as well, versus a piece of paper where you can actually use just a pen and that's it. Cheaper and more reliable in very tricky environments, isn't it? The key here, I think, for technology is really to understand what's the value that it can bring. So computers are great at processing great amounts of data. We can automatize things. No, why having to fill in a form when we can just with 3 clicks do it, and instead of 20 minutes investing on it, it's done in seconds. No, it's a very interesting area to explore. No, not just thinking we need just to put everything on a computer, but actually how to make the computer work for us. No.
Yeah, and to if you start on latest one you said, it is very common. I mean, it's all around the world that first responders get tablets, or likewise, or if they're really savvy, they get a Google glasses or whatever. But they have this tool to be able to report things. But it's generally not to help of the individual firefighter. It's the system behind the firefighter. It's rear command and so on. So they want you to fill in things rather than doing it on a piece of paper, because the value is later on in the incident is to the officers arriving. But usually, because of how the software maybe is written or how it's done, it is an added workload, or at least it feels like an added workload on an already stressful incident command. I would say that if you're a first arriving officer and you have time to put up an iPad, you're almost doing it wrong. I think the software is wrong. That's why, because I think it needs to be passive. I think it needs to be, again, I would like a 360 thermal imager, normal imager camera rotating on the skull of the incident commander, and that passively collects information, which someone else puts into the iPad in some format. It passively collects that data, and then you get active help as an incident commander by someone tapping you on the shoulder and saying, hey, have you thought about this building type? It might collapse any minute. Maybe you shouldn't be in there. Like, that is an added help. It's not an increased workload. So I think that's very important. And to the other point you made, I absolutely agree. If you make a system that only works for rear command, and there's specialized people that's going to do it and so on, it will not be adopted really well. It would not increase. And because the value is limited, it's hard to, you have to learn the system and so on. If you build something that works for the small incidents, it probably works for the larger ones too, and it helps adoption and everything else. So I totally agree. You shouldn't build a system that's for rear command, that's for big incidents and everything. Your mindset should always be, if I would start, I would say there is an individual from the public going out to a fire. That's where you start. So they call 911, they're standing outside the building. So they can take up their phone and they start shooting video. That's where the system starts. That's where you start collecting data. And at the same time as this happens, you have someone starting to supporting that public person. Like, maybe you should use a dry chem extinguisher. Don't run into that building. It looks dangerous. Try to do this. If you build a system that works for the average person, like the grandma that hardly knows how to use a smartphone, now you're getting close to what firefighters can operate. Because we're constantly overestimating, and that's not a looked at bash on firefighters, saying that we're technological and what do you call it, technological cavemen. It's not that. It's just that we don't have time to operate anything that's doesn't intuitively know how to work. Like, because the training hours required to learn something complicated is not there. As an example, we got new radio systems in Sweden many years ago. Radio before that there was 2 buttons, sort of, one to talk, one for changing volume and maybe change the channel. So whenever you train the radio, you train on what to say, how to say it. You train on the procedure, you train on the goal of communication. That transition into learning how the radio operates, because now the radio has 1,000 buttons and 1,000 functions, which nobody uses anywhere in the world. You just want select a channel, push to talk, listen, like volume. That's all you need for 99% of all firefighting. But then you had putting training hours to learn the system of the radio, not how to talk and when to talk and so on. So you actually became worse firefighters with the adoption of better technology. Now the system was better because it was digital, it was cryptated, and there was a lot of benefits. But for the first driving officer, I would argue that it was a worse system for many reasons. And again, that is the problem. It has to be ridiculously simple. And that means that it has to be sort of passive for the first responding unit. If that's a civilian, if that's a part-time firefighter, or some kind of, hybrid between those, that you have some kind of media, you respond with just an app on your phone, like with CPR and so on. You're like a volunteer. Or for that matter, if the Firenerd Lars is coming, it doesn't matter. I do not want another workload. There's too much to process. So build a system that works for your grandma, that's passive in that regard, that it only collects data and helps her actively when another brain has interpreted that information, or preferably 1,000 brains. Then I think it could work. If it's user dependent on the front side, if the officer out on scene is the one who's supposed to do the starting the unit and collecting the data and analysis, make an analysis of it, and then do some kind of action, I don't think it works. At least not well.
Nice. So focusing a bit on another comment that you were doing at the beginning, no, it's really about this adoption of specifically, no, on the thermal imagery component. So what are the main kind of like specific barriers or challenges that you've seen on the fire services you trained to really adopt this specific case, like this specific technology?
Well, interiorly, well, besides the fact that it's an added workload, it's an added thing to do. And again, all things you add takes up more time to analysis. So if you, let's say you go to a fire and there's pretty good visibility, like you have some sort of visibility, you can see the room around you, and there's a fire being, like, the fastest you can do, of course, is run through that apartment and see where the fire is and get it. If you slow down and take time to really scan with the thermal imager and add that time it takes and that analysis process, you're just going to be slower. It adds something valuable, which is not more information, but it takes away speed, it takes away things. So it's not natural that thermal imagers always are better. But if we take a fire where you have smoke to the ground and we start with interior thermal imagers, just probably, it's not always the case, because sometimes you don't have any vision at all, depending on the situation. In a lot of cases, it's just so superior that it's a paradigm shift. And I would say paradigm shift from firefighters trying to find their orientation throughout walls. And a lot of times these days, you'll take with thermal imaging, the fire is over there. Yeah, let's go that way because that's where the wall is. And it's just insane. It's just nuts. We've passed that long ago. You go straight to the fire. Now, what happens if the thermal imager breaks? Well, you just reverse along the hose line to the closest wall, and then you follow the wall. It's not that complicated, but that simple switch, most departments in the world has not done that. Now, there's more ways to search with a thermal imager. You can have officer-oriented tick search and so on, but just to explain. And then you also have, of course, the increased efficiency when doing suppression. Like if you throw water inside of a burning building, you can't see anything. The thermal imager allows you to assess that situation. Where's the fire going? Where's the water going? What happens to the heat when the water goes there? Am I doing permanent changes or just temporary changes and so on? So the ability to analyze what the water is doing, of course, is a main difference. So also suppression, which is highly not utilized at all in firefighting. And you see, I have of course, as a nerd, I look at evaluations from fires. I look at tons and tons and tons of YouTube videos. And when you see thermal imagers being used, they're basically a lot of times a very heavy sledgehammer, because they're perceived to take up time rather to give you time. And I think that's maybe it's, 5 years ago, even 5 years ago, the cameras weren't nearly as good as they are today if you look at the good ones. So the value you got from them was lower, and maybe that added to the skepticism that exists today. But again, so the utilization of cameras are overall very low. Now, if you go to the outside of the fire, that's the utilization of thermal imagers is almost none. And I think that's also, it's one part of that is we're not used as a fire service to do interventions or, suppressing the fire from the outside. Sweden started with 20 years ago with different types of piercing nozzles, and piercing nozzles exist all over the world, but they generally haven't been used that to any large extent. It's been a specialized tool for special fires. But if you have a void space fire, the natural way to go is to put a piercing nozzle in Sweden. I would say it is the natural way, or at least I hope it is. We have strugglers also that's lagging, but then so even the baseline, we haven't really done exterior firefighting as a fire service in the world very extensively, which means that we haven't really had the need to assess the building thermally from the outside. Now, if you take the shift in how effective it could be with a piercing nozzle or a stream from the outside or whatever exterior suppression methods, and the capability of the thermal imager to see, oh, we got heat signatures coming from the attic, or we got heat signatures coming from this wall section. The ability to do something early in that case, of course, increases tenfold. Now, there are problems with that also. Again, analysis, there's more information to draw from. But even if you don't want to do an attack from the outside, it's easier. Maybe you can see, okay, it's that apartment in the apartment complex. So I know where the interior firefighters are supposed to go. We get a head start, maybe, compared to if you don't do anything at all. And I was at thermal imagers through drones has not been common. Now, I was at a training exercises just today where we burned the house down. I do a lot of acquired structure burns to train firefighters and to learn myself. It's just fun. but there was a drone there with thermal imagers, and of course they can see on the like when the house started burning, you can see how's the thermal radiation affecting the surrounding buildings, and you can move that drone around and see where that's hitting. Now, that's a fantastic technology because you get different angles, of course, than you get from the ground. You can see how the roof is doing and outside the roof, and it's much faster to just go with a drone to look at different sides of the building compared to someone walking. Now, the only problem with that is, as we talked before, is that you have to have a drone operator in that case, because it's a piece of technology it's getting simpler. It's almost ridiculously simple to fly a drone these days, but you have to have an operator. And if you make the incident commander the operator, you're going to probably fail because they don't have time to learn that. They don't want to learn it most of the case, and they don't have time doing it. So you have to have a drone operator. And then the second problem, you have to have a drone operator on a shift, and it's probably you can't have one in every station. So that's a pretty late resource. It's not there the first 2 minutes. Maybe Romeo can fix that. So there's a drone on my head now, go up and on my first, and so as soon as I step out of the car, it lifts or on top of the fire truck. That's his gig. I don't know. I would love to have one, but I don't want to look at the picture. Probably, I want to have someone else look at the picture and tell me what it says. Like, do you need to see this? Because we're looking at it. If you have a drone operator, and that drone operator not also has to fly the drone, they also have to interpret the information on what it sees, like on the video. Is this important or not? And that requires a lot of subject expertise, not just on, for instance, firefighting or hazmat, whatever it might be. It also requires knowledge about what do the incident commander needs to know at which time. So that the analysis process is very hard to obtain. Like if you have a resource that goes out, and typically in Sweden is a firefighter going out, and they're technically good at the drone, but they're not necessarily good at evaluating what the officer needs to know in which time. If you have that analysis capability on rear command, where it's much easier to have centralized good analysis functions, that will increase it. So I hope that Romero builds an automatic drone, of course. So we remove the drone operator. There's a drone on every fire truck, or for that matter, every house. I don't know. Orwell's fantasy is coming true. of the surveilling state, but at least on every fire truck, so that it launches automatically, and we can have that analysis capability on rear command. Or for that matter, when I say rear command, I don't mean a house where everyone sits all the time. I mean shoots out to smartphones through the whole organization. For that matter, the neighboring organizations say, hey, we need help with analysis. Do anyone have time? Sure, I can put up my smartphone and do resource analysis or building construction analysis or methods and tactical choice analysis. So whatever my brain is supposed to focus on.
Yeah.
Sorry, I'm rambling.
No, you're touching many interesting topics, actually, and actually this opens very much the floor for the Romeo part of the presentation. So to give a very brief intro about Romeo, who I have the pleasure of knowing for quite a long time already. So Romeo is actually one of the key people that have been pushing and developing drone technology for public safety. He is currently the VP of Public Safety for Auterion, which is this new platform for like an operating system based on open standards to be able to enable all this data sharing. And also, well, from all his experience, he has also been involved in real emergencies and real disasters like the wildfires in California. So, Romeo, I'll pass over to you, and then, yeah, we can continue this very fascinating discussion. Also, for the audience, you have the option of putting your questions in the Q&A, and after Romeo presentations, we'll have the chance of discussing it with the panelists.
Thank you. Thank you, Alfonso and Lars. Wow, so many great points. And I'm going to build on those points from the drone perspective side. I'm a very visual person, so I'm going to just see if I can get my slides up. Alfonso, it says hosts disabled.
Yes.
From sharing. So I'm going to just, until Alfonso helps me figure this out on the back end, here we go. We are fast working here, just like in a real situation. All right, here we go. Situational awareness, the building the ecosystem. This is the theme of this webinar series by Unblur, and thank you for having me. My focus is really going to be on that ecosystem piece, as well as the data that Lars, really focused on. That it's coming in like a waterfall, and oftentimes all you can do is stand underneath it, look up, and maybe open up your mouth to get as much water in, but it's just overflowing you. So what are we doing? First of all, thank you. Yes, I am the Vice President of Public Safety here at Auterion. It's kind of a new position for me. I started 6 months ago. Before, I spent my time at the largest drone manufacturer, really building the public safety side of this technology. But we had reached a point where my vision didn't go any further, and the technology capabilities back then didn't go to that next step where I think it needs to go. And hence why I decided to make this change, so we can really tackle those issues that Lars highlighted in his talk. Auterion, we're not a hardware company. We're not building the drones, but we're building that important piece of drone software. And we're an open source software company, and we supply the enterprise operating system for unmanned vehicles, not just drones. This can be a ground rover, a water unit, underwater unit, and an aerial-based unit. So it doesn't have to be just the drone, but the key is it all is around one common operating system that allows you to operate and gather data from all these different systems. So standardizing it, that's already a big key component. We are located with our R&D headquarters in Zurich, which just happens to also be the place where I grew up, but now I live in Silicon Valley. And we have our offices here as well as in LA. We have a US headquarters in LA, and we also have an office in Munich. So we're very European as well as North America centric. which is a really great place to be. But if you think about it, we are in essence the Android for drones or unmanned systems, not just drones. On the Android side, you have one operating system and you have multiple manufacturers you can get your tablet or your phone from, and it all works the same. And that concept applies also to Auterion. You can have a rover, you can have a VTOL, you can have a multi-rotor, and it has the same operating system, the same user interface, the same way to share data. And suddenly you're much more standardized than before. Now, the key is choices, which I tie back to the ecosystem. There is no one company that from now on in the future can do it alone. And that is a really, really important realization, because we have now learned so many use cases. Just in public safety, we have now 20 or so use cases where we need different types of platforms, different types of sensors. So having that ability to bring in a larger ecosystem that operates on an open source standards is just exactly what is needed. And that means we can now use a whole variety of different technologies, from, like I mentioned before, your fixed wing, VTOL, multi-rotor, ground rover. And by having autonomy and AI on board, we can assist the entire operation. And that can be from the flying part, so that that incident commander doesn't have to be the operator, or that dedicated drone operator doesn't really have to be the operator, but also analyzing data in real time and giving us just the pieces that we need. Autonomous navigation, mesh, and 5G communication. The idea is not having an SD card in a drone where you have to take off data, that your data is being streamed from the unit in the air to wherever it needs to go. That can be either locally or an incident command that is kilometers away, so that everyone in real time gets that information. And then have the industry leading sensors and payloads be part of this ecosystem, because maybe we need a thermal imager from FLIR, maybe we need a gas monitor, maybe we need a plume modeling solution, that they all have access to this hardware that is being built by different manufacturers, but operated under one user interface and one standard. So in essence, what we do is we have multiple pieces, and one is the mission control. And the mission control, we're very familiar with this in the drone world, where you plan your missions, you execute your missions in, where you get a lot of features, autonomy features, like flying a grid for mapping or flying a point of interest. That's nothing new. We're allowing operators to do this on laptops, tablets, or on the ground controllers. It has checklists. That is nothing new. As well as the Auterion suite, that's where your data comes in. And here is something that we're doing very, very different, because the drone is in essence the connected device, because the drone is sending out all the data, and because it's on an open source, open standard platform, health data, which means in real time, we can see what is happening with all our units in the air. And that allows us for even higher risk mitigation and compliance reporting. That is absolutely where the industry is going. And it's very exciting to see that added safety feature. So let's go a little bit back in time. In 2016, we did an ENA, the European Emergency Number Association white paper. And that was really the first time where we looked at 4 different departments in Europe, from the Greater Copenhagen Fire Department to Wales, down to Iceland, over to Iceland, down to Donegal in Ireland, to see how would these departments integrate drone technology and what would the benefits be. And even 5 years ago, we identified that there is so much data that needs to be digested. We need actionable data. 80 to 90% of the data that comes back is potentially useless. You're looking for 10 or 20% only, but you have to shift through all of that data to get that 10%. What can we do to eliminate that what Lars called that analyzation paralysis moment? And then of course, standardization. Those were the items that we identified. And if we go back in time and we look how drones were deployed over the last 5 years, how it all started, it's very fascinating, because in the beginning, this is how it started. And many departments still start this way. We have a structural fire, we launch a drone, we have a drone operator, and we have a battalion commander, incident commander, right behind that operator, looking over the operator's shoulder. Now we have two people taken out of commission because they're both so fascinated by seeing what's happening. And that just was not the best way to operate. So you have a data bottleneck in essence. All right, then we realized, wait a second, if we have an HDMI connection to a monitor, we can now separate the incident commander from the drone operator, which is really great because we're creating this sterile cockpit environment. But now the incident commander is looking at an additional screen and can still get distracted by all this data that's coming just from the drone. Then we started to do live streaming, and that's fantastic. So we still have the option to get information on site on a bigger monitor, but now we can also stream it to off-site areas where people can look at it and also get potentially a common operating picture or situation awareness from afar. All great stuff. And then just a couple, 3 years ago, we started to see the drone as a first responder concept, where the drone actually takes off from the station and is being flown to the incident site while units are still en route to that location, already providing some initial assessment of what is awaiting the individuals. There's the first responders en route. The problem here is, due to current regulations, you still have a lot of operational and manual tasks that are involved. You have people that are on the roof, keeping visual line of sight of the drone, and it's just not as integrated. But today, we are at a place where the drone becomes an IoT device, a device that is connected and is sending data anywhere where it needs to go. And at the same time, we can operate it in a fashion that in theory doesn't require additional resources to be operated. Regulations are catching up to all of this, and we are starting to see tactical beyond visual line of sight approvals from authorities. We're starting to see beyond visual line of sight flights that are happening. So we're getting there. So this is kind of like the progression of how we have gotten to today. I just got back from a vertical takeoff and landing, a VTOL platform validation project in a simulated hazmat scenario. This is a very new concept. This is the next frontier of drone technology. It's this fixed wing aircraft, as you can see here, that also has propellers to lift it up and down like a helicopter, but then transitions in flight to a forward flying fixed wing platform, allowing for up to 2 hours of flight time. Now, immediately you see the benefit: long duration and small areas to take off and land from. So we wanted to start validating this technology. And the scenario was a train rail cart that had a leak. Additional technologies were utilized, like the squishy robotics units that are being sent or thrown into the area that collect visual data as well as other types of data. And we utilized the VTOL at a high level, 120 meter above ground, 400 feet above ground, doing big loiters, big circles, point of interest, just giving high level situational awareness of the incident, integrating Atech, which is a geospatial solution to track ground units. It's the Android team awareness kit, where you can see where are your units on the ground, from your firefighters to your command vehicles to everything that you tag, and keep a very high level situation awareness while you're still flying multi-rotors at a lower altitude for very specific tasks for, 10, 20, 15 minutes, depending on the battery lifetime of the unit. And all of that data comes in, and incident command has access to this data, but we're still dealing with this overload of data in essence. And so there are still a lot of challenges we are tackling and are being tackled by a variety of different solutions that help us stream down and filter the data. So really only the most important pieces are coming to where they need to be. So what does that look like what does the workflow really look like in real life? Well, on the top line, we have the department level. That can be either the station, that can be a field incident command area. And then on the bottom side, we have the on-site, where the drone is being flown, taken off. And in this case, we're looking at a wildfire situation. We're doing mission planning. That's being sent on to the operator on site. The operator launches the drone. It can be a VTOL, it can be multi-rotor. They're flying the missions, sending back data. That data can then get straight integrated into your solutions. In this case, it would be potentially an Esri solution. So we get actionable data back from Esri. This can be Unblur, where it got into Unblur solution for situational awareness on the ground. You name it, this workflow can integrate into those third-party workflow providers. And now you're seeing that at no point in this process, we're touching an SD card. And that is really where the workflow process, not only in public safety, but other verticals, has to go. So in essence, what we're really focusing on is enhancing the public safety. And there's really three areas that I like to focus on. And that's the simple and intuitive UI, the user experience. Like Lars mentioned, it has to be simple. It has to be fireproof or police officer proof. It has to be so that there's a couple of buttons to press and it's doing what it's supposed to be doing. We're adding that 4G or 5G or mesh network delivery methodology to the drones, which has not happened to date. And we're also adding additional computing power and resources on the platform so that we can run algorithms on board to assist with the data analysis part of the challenge. I'm not going to go too much into all of these different things, but in essence, just visualizing a planned mission in 3D already changes your risk and safety parameters, because now instead of just looking it from above and you have no idea, well, will I actually clear all obstacles? Just now seeing it in a 3D environment is just a very simple way to pre-plan a drone mission. Of course, connectivity is the keyword we've been hearing over the last several years, and we're seeing more and more technologies come online. And the challenge just becomes bigger in aggregating all that data into one area, because if you have 5 technologies, but you have 5 different systems, and you have to check 5 different monitors for each of those systems, then you're adding additional workload that we're trying to avoid. And of course, this is really, in my opinion, the big opportunity here for the ecosystem to come together and help provide solutions that run on the edge, on the platform itself, to help with analyzation of data, with tracking of information pieces. And that's just going to increase over the next couple, 3, 4, 5 years. And the way we are utilizing this technology will change, because it's about the data. Yes, these are beautiful hardware pieces. The drones look beautiful, they fly beautiful, and they will continue to become better, but it is about the data. And so what we're really trying to do is we're trying to bring together the ecosystem of drone manufacturers and payload manufacturers so that they can create solutions and we can mix and match drones as well as payloads with each other. And in essence, this is depending on your mission. You pick your drone, you pick your payload, you pick your software, and you pick your end piece and actionable data piece, and fly the mission gives you much more flexibility than what we used to have before. And so no matter if you're flying a VTOL, a multi-rotor, you're doing a delivery, having one ground controller, having one user interface cuts down already on not only training, but it improves standardization, efficiency, and really allows to do multiple things through a much, much simplified process. If you have any questions, here is my email. Obviously, we have a few more minutes to do Q&A, but I truly think that we are in the right direction. We're going in the right direction. We've realized that data is the key piece, that we need to scale down data so that the most valuable information are being presented. And we need to do that autonomy piece so that, like Lars said, in the future, he may walk around and have a little drone take off from top of his helmet or of the fire truck. But that's exactly where we need to go.
Nice. Thank you, Romeo. Very, very insightful presentation as always. I think it's we are touching in a very, very interesting thing, no? Like we were saying before, we tend to see about the technology about like, yeah, look at this piece of data, no? And now we're starting to switch more about like, okay, yes, but for this to be really something of purpose, how can actually the machine work for us, no? And this is, if you see like other sectors that have been changed by technology. If you take, for example, traveling, no, before it was about finding the flights, and you have the searchers, etc. But then the thing was like, okay, you have all this information about flights. What's the best flight? I don't want to see flights. I want to say what's the best thing that works for me, no? So it's this switch from I don't have data, now I have data, now knowledge. It's not about having information, it's about having knowledge, no? What do I do with it? Yeah, so nice. Do we have any questions for Romeo? I see that there are like a few comments in the chat.
Mike asked a good question about Atech. He is exploring the use of Atech and wanted to see if there are any research and case studies. So this is a great question, and I think we're very early on in utilizing Atech or CivTech for the civilian side. Atech came out of the military area and is now adapted over into the more civilian side of things. And it's fairly new for public safety, the concept of this really geospatial tracking and situational awareness piece. So I don't know of a lot of research or case studies, but we are in the process of doing our own studies and improvements upon Atech. Atech is not very, at this point, the real Atech piece is not really as user-friendly because it was built on the defense side, on the military side. And so now through the open source and open standards piece, improvements are being made. But for that high level situational awareness, where we have like a VTOL, where we fly a very large circle around an incident site, and at any given point, we see the incident from one of the 360 degrees with everything outlined, who is where and what is being done. That to me, conceptually, is an amazing thing to do. Search and rescue, disaster response, hazmat scenarios, those long duration events are the perfect opportunity for this kind of additional piece of information. Now your everyday structure fire, I don't think warrants a VTOL nor warrants Atech potentially. You never know. Maybe we're getting to the point where we also have the tracking capabilities for indoor deployments, where we now see the two firefighters are on the second floor in that room on that side of the building. Once we get to that point, then it makes even more sense to deploy this technology even on smaller incidents. So I think, Mike, we're getting to the point where more data, where more research and use cases are coming to light, and as a community we will learn together on how to better implement and improve that.
Nice, thank you, Romeo. I think it's for me the biggest takeaway again, no, it's on how can actually technology do more on simplifying all this information, no, because we have more and more devices. The indoor location component, for example, our colleagues from Midwest Wales Fire Service, they had a very interesting project on indoor tracking, and they had a couple of startups developing some devices that were actually operational for fire environments. And the key question was actually after, yes, how do you actually absorb this information, no? And then what do you do with that piece of information? Could we actually have artificial intelligence or something like this, like this spider that Lars was mentioning, being like an assistant more, no, of the incident commander, being able to understand what's going on and be able to share insights, just like any other assistant that you may have. But this one never gets tired, and you know that it's very cold and calculative. It's a computer. So just ask the right questions to it, you know, don't depend too much on it, but it can actually be able to bridge all of this, no? Nice. Okay, so we are running out of time, so I don't see any further questions on the chat or on the Q&A. Well, to close up, I wanted to give you a really strong thank you to Lars and to Romeo for sharing your insights with us and having this conversation. I think it's very insightful to listen to people with both of your experience. And yes, looking forward for the next webinar, and yes, to have further chats with all of you. Thank you.
Thank you for having me. I hope that you build a perfect system for me.
Teamwork.
Teamwork.
Yes.
That's it. Perfect. Cheers, everyone. Bye-bye.